Hi, this is Giridhar from eMath. As eMath, this video series is an initiative of a free chapter-wise revision for all SSLC students of Karnataka. In this video, let's revise the chapter Real Numbers. Chapter 8 Real Numbers. So in this chapter, we are going to discuss about the first topic is about Euclid's division lemma, also called as Euclid's division algorithm, right? So the statement says that given two positive integers a and b, there exists unique integers q and r such that a is equal to bq plus r, 0 less than or equal to r less than b, right? So let's see what is the meaning of this statement now. So for any two positive integers a and b, there exists another unique positive integers q and r such that this condition holds good. This condition is true, right? What is that condition? A will be equal to the product of b into q and added to r plus r. Okay. Provided there is one more condition for this particular equation. What is that? The value of r should lie only between 0 to b. It can be equal to 0, but it can go beyond 0, right? That is 0 should always be less than r, or r is always greater than 0. That's the meaning of this statement, right? So this is about Euclid's division lemma, and we also have one more. What is the meaning of this lemma? A lemma is a proven statement which is used to prove another statement. Okay. Then we also have one more topic of this chapter called fundamental theorem of arithmetic. So let's see what is the statement of that theorem. Okay. So every positive integer can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So what is the meaning of this statement? So every positive integer, we can express it in the form of a product of all prime numbers, and this factorization is always unique. It's a unique means it's a single number, okay, apart from the order in which the prime factors occur. This is the meaning of this statement. And then we have this revisiting irrational numbers. You know what is this irrational numbers now, right? So we have a theorem in this chapter. The theorem says that let p be a prime number if p divides a square, then p divides a, where a is a positive integer, right? So what is the meaning of this statement? For any positive for any prime number p, it always if it divides a square, then it always divides a also. That means if a square is a the perfect square number, okay, if any prime number divides perfect square number, then that prime number also divides the square root of that particular number, where a can be any positive integer. That's what the theorem says. Then let's look at the illustrations. Illustration 1, it says if HCF of 52 and 182 is 26, find the LCM. So we know that there is a relationship between the given two numbers and the HCF and LCM, right? That is, the product of HCF into LCM will be equal to the product of the given two numbers. So we can actually solve the value of L like this. That is, the product of A into B divided by H. And then the product of given two numbers is this 52 and 182 in the given problem. So that is substituted over here, and then divided by H is nothing but the HCF of the two numbers, which is 26, right? So 52 into 182 divided by 26. After cancelling each other and then multiplying, we get 364, which is the answer for this LCM of the given two numbers. Hence, the LCM of 52 and 182 is 364. Now let us look at the one more illustration. Illustration 2. Okay, it says prove that root 3 minus 5 is an irrational number. So how do you prove that root 3 minus 5 is an irrational number? We can prove that this number is an irrational number by making use of this root 3 as an irrational number, right? So we know that root 3 is an irrational number, and the terms whatever it is included along with this irrational number will be again an irrational number. So we need to make use of that. Okay, so let's see how we do it. Proof. So firstly, let us assume that root 3 minus 5 be a rational number. So what if it's a rational number? If it is a rational number, then root 3 minus 5 can be expressed in the form of p by q, where p, q belongs to z and q is not equal to 0. So what is the meaning of this? P, q belongs to z. That means p and q are integers and q should not be equal to 0. Correct? Then the next step is about root 3 is equal to p by q plus 5. If this minus 5 is getting transposed to right hand side, it becomes plus 5, right? So root 3 will be equal to p by q plus 5, and then the next step is taking the LCM of this term and simplifying. We get this root 3 will be equal to p plus 5q divided by q. In turn, it can be written as r by q, where r will be equal to p plus 5q. P plus 5q. Okay. So root 3 can be expressed in the form of a fraction, right? So this is wrong, but we know that it cannot be expressed in the fraction because root 3 is an irrational number, right? So uh, this is a contradiction to the fact that root 3 is an irrational number, right? Hence our assumption that root 3 minus 5 is rational must be wrong. Therefore we conclude that root 3 minus 5 must be an irrational number. So this is how we prove that some number, some expression which is involved along with an irrational number will again be an irrational number. So root 3 minus 5 is again an irrational number, right? Thank you. We will get back to you with the revision of next chapters.